Let's look at adding and subtracting rational expressions next. To add or subtract fractions, you must have a common denominator, and it's the same for rational expressions. Now, we're going to start with problems that already have a common denominator and then move on to look at how to find one. Let's just review the process if you do have a common denominator. Remember, what you're going to do is simply add or subtract the numerators based on what you're told, and then keep that common denominator. The reason you keep the common denominator is the denominator is representing the size of the object you're adding. So that's part of why you need a common denominator to add things, because you must add things that are the same size. For instance, you wouldn't add 15 inches directly to 2 feet. Inches and feet are not the same measurement, and the denominator is telling you the measurement of the object you're adding, so you must have a common measurement for that to work. Now, at the end of the addition or subtraction problem, once you have a single fraction, then you can try to simplify, but you never simplify ahead of time. You always simplify at the end when you're adding or subtracting. So be careful about that. Simplifying at the beginning only works when you're dealing with multiplication. So you should always wait to simplify until the end with an addition or subtraction problem. So let's look at a couple of examples. These two examples, one addition and one subtraction problem, both have a common denominator already. In the first one, we have the fraction x plus 3 over x minus 1 plus the fraction x plus 2 over x minus 1. So we have a common denominator of x minus 1. So we're going to keep that common denominator and then add the numerators. So we're going to add x plus 3 and x plus 2 together, and that's going to become our new numerator. Now, I wrote that down to emphasize it, but you could just go ahead and add them as you go to that next step. And in fact, what I would normally do is just add them and get 2x plus 5 automatically. So to go from here to here. And then we still have the denominator of x minus 1. Now, we would want to try to simplify this if possible, but to simplify, we have to be able to factor and look for some common factors that are exactly the same. There is nothing here that would factor in either the numerator or denominator, and 2x plus 5 is not the same as x minus 1. So these factors are not going to cancel because they're not the same. Be really careful not to cancel the x's there. The x is not a factor of the denominator. This x is not a factor of the denominator because it's not common to the entire denominator, so it cannot be canceled. So just remember that you can only cancel things that are multiplied by the entire numerator or the entire denominator, not added or subtracted. In our second example, we have a subtraction problem, but luckily we do still have a common denominator. So I keep the common denominator and I subtract the numerators. And I do want to point out one thing here. When we subtract numerators, we need to subtract all of the second numerator. And that means distributing the subtraction. So we're going to subtract 3n, and then when we subtract 8, that's actually adding 8, because we're subtracting a negative 8. So the subtraction and the negative kind of undo each other, and we get positive 8. So remember, if you have more than one term in your second numerator, you're going to need to distribute the subtraction. Now, collecting like terms, we have 2n plus 10 over n plus 5. Now that we have a single fraction, see if you can simplify. To do that, factor, and we're lucky here, we have a common 2 in the numerator. So we have 2 times n plus 5. And then in the denominator, we actually had an n plus 5. So here we have a common factor, n plus 5 in both the numerator and denominator. We're always going to be left with 1 when we cancel. And so this becomes 2 over 1, or just 2. When we cancel, though, we want to remind the reader that what we've canceled, which was in the denominator originally, this n plus 5, can't be 0. So that means that n cannot have been negative 5, because a negative 5 would have made that thing that we canceled 0. And we have to tell the reader that because that n plus 5 has disappeared. So our final answer is going to include this domain restriction of n not equal to negative 5. Here are 2 more examples of adding and subtracting rational expressions. Remember, we need a common denominator, and at first glance, these fractions have different denominators. In fact, they do have different denominators. But I want you to look a little more carefully here, because those denominators look awfully similar. One thing to note, and I've been trying to emphasize in all these videos, is you should always have each of your fractions written in the same way, the numerators and denominators. And when you look at this first fraction, The first numerator starts with an x and is written in descending order. So is the denominator. The second numerator is as well, but the second denominator here isn't written in descending order. And that's a hint that there might be a negative lurking there. So I'm going to rewrite the problem, and I'm going to factor or rewrite it in descending order, and then factor that -1. So as you can see, there's a -1 here. So if I factor that -1 out, I'm going to have -1 in my denominator times 2x. Remember, a positive divided by negative would give me a negative, so I'll have a -1 there, and then x plus 5. So my denominators are almost alike. The only difference is this -1 right here. Well, a reminder from fractions, in general, you can have a negative out front of a fraction, or you can have the negative in the numerator, or you can have the negative in the denominator. Right now we have it in the denominator. It might be better, in fact, if I got it out of the denominator, I would have this common denominator. Why don't we move it to the front? So let's move this negative up into the front. And so it changes the subtraction to a plus, because when you have a minus times a -1, it becomes a plus. So our operation changes. So instead of having a subtraction problem here, we now have an addition problem, because we've moved that negative into the subtraction. So now we do have a common denominator. So we did have a common denominator that was kind of lurking there. We just needed to move that -1 up. Something to always watch for when you have those expressions written not in descending order, there may be that lurking negative. Now that we have the common denominator, let's write the problem that way and add the numerators. X plus x is 2x, and 3 plus 5 is 8. Now we could try to simplify this, and in fact we could factor the numerator, but even if I factor the numerator, and I'll show that here, it's not going to help me cancel anything, because I'm going to get x plus 4, which is not common to the denominator. So there's no way I can simplify that. So you can either leave your answer right here as 2x plus 8 over 2x minus 1, or you can leave it as 2 times the quantity x plus 4 over 2x minus 1. Both are perfectly acceptable. We don't have to provide any domain restrictions because we really didn't cancel anything there. So everything that would be a restriction in the top is still a restriction in the final result. In our next example, once again, we have a denominator that's not written in descending order. So let's go ahead and rewrite it in descending order before we do anything else. So I'm rewriting the problem, a squared over a squared minus 1 plus a plus 2 over negative a squared plus 1. And then I'm going to factor that -1. When I factor that -1, what I'm going to have is a squared minus 1, which is basically what I had in my first denominator. So if I remove that -1 from the denominator by moving it out front of the fraction, I will then automatically have common denominators. So looking for these -1 factors can sometimes help you out quite a bit. So this is going to be minus the fraction a plus 2 over a squared minus 1. So I now have a common denominator, keep it, and subtract the numerators. So I'm going to have a squared minus a, and then remember to distribute that negative all the way through, so this becomes minus 2, not plus 2. Now that we've got a single fraction, maybe we can simplify. To be able to see if we can simplify, we want to factor. So let's try factoring the numerator. A squared goes to a and a, -2 goes to -2 and positive 1. Those add up to a -a. And then the denominator is a difference of squares, a plus 1 times a minus 1. So what we have here is a common factor of a plus 1, which can be simplified so that my final answer becomes a minus 2 over a minus 1. We did cancel something here that no longer shows up in the final result, so we must show the domain restriction. We canceled a plus 1, which means that a cannot be equal to -1. Make sure you write that domain restriction in.